Greetings, y'all, and welcome to your favorite math vids. Welcome Eugene up here in the top right corner. He's making a special guest appearance for 0.8 on factoring linear expressions. Okay, so this is basically just a review of factoring. If you probably haven't factored for a while, actually. So, review. A monomial is a number, a variable, or a product of a number and one or more variables. So, monomial just means one, so it's one term. So, just 25, that's a monomial. If we just have x, that's a monomial. Or if we have 40x, that's also a monomial because it's one term, but this one term does have two factors, 40 and x. But those are all monomials. These are not monomials because there's two terms. There's 1, x plus 4, that's two terms there. 40x plus 120 is two terms. Okay. To factor a number means to write it as a product of its factors. A monomial can be factored using the same method you use to factor a number. The greatest common factor, or GCF, of two monomials is the greatest monomial that is a factor of both. Okay, so that's a lot of words. Let's see what that means. Okay, so this is find the GCF of each pair of monomials. So we have 4x, and we have 12x. Okay, so we can always do this like factor tree thing where we break down, this is 4 and x. 4 breaks down to 2 times 2. 12 breaks down into 12 and x. 12 breaks down into 4 times 3. And 4 breaks down to 2 times 2. So then we look at what they have in common. So they have 2 and 2, another 2, and they have an x. Okay, so all of those are going to be our GCF. We're going to multiply them all together. So 2 times 2 times x. And we're really just leaving out that 3 there. So that comes out to be 4x. So 4x is the greatest common factor of both of these. And it just is a coincidence that the original factor was 4x as well. Okay, let's try this one. So we have 18a and 20ab. So 18a breaks down into 18 and a. 18 breaks down into 9 and 2. 9 breaks down to 3 and 3. So that's the prime factorization. 20ab breaks down into 20ab. AB is just a and b. 20 is 10 and 2. 5 and 2. And now we need to see what they have in common. Well, there's no 3's, so there's no 3's in the 20. So there is a 2. There's an A, but that's about it. So our GCF is just going to be 2A. And then the rest of these things do not match up. So those do not belong in the GCF. Okay, another one. It's a little bit more complex. So 12, c squared d to the third. So we have 12. I'm going to bring my number over here. Variables over here, c squared. D to the third. On this one I have 36, c d to the fifth. 12 breaks down to 4 and 3. 4 is 2 and 2. C squared and d to the third. C squared is c times c. D to the third is d times d times d. Running out of room here. 36 is 3 times 12. 12 is 3 times 4. 4 is 2 times 2. These ones break up into c and d to the fifth, which breaks up to 5 d's. 2, 3, 4, 5. Okay, let me separate these a little better. Okay. All right, so how many 2's do they have in common? Well, they both have 2 here, 2 here. Both have 3's. So all these ones that we've broken down, like this 4 is gone. The 12 is gone. These are all gone. So we've broken them down further. So we're only looking at the ones that are remaining. So that 12's gone. This one's gone. That one's gone. Okay. And they also have 1 C in common and 3 D's in common. Okay. So our GCF is going to be 2 times 2 times 3 times C times D to the third, because there's 3 D's. Simplify that, we get 2 times 2 is 4, 4 times 3 is 12, times c, d to the third. Okay, so really, if you can look at just the numbers and find the GCF quickly, you know that's 12. Then if you look at your variables, we're just going to pick whichever one is the lowest. So this is c squared, this is c. So I know they're going to have one c in common. This is d to the third, this is d to the fifth. So I know they have at least 3 d's in each of those. So we get 1c, d to the third. And your 12 is the GCF of the numbers. Okie dokie. Okay, so which of the following is not a factor of 22x? Okay, well, x is obviously in 22x. 22 breaks down into 2 times 11, so those are both factors, so it's got to be that one, 4. 4 does not go into 22. Don't mind my roommate's dog. He likes to bark at things that don't exist. All right, so I'm going to have you try these 3 problems. Okay, you're going to find the GCF of A, B, and C of all of these. Okay, go ahead, pause this in 3, 2, 1, pause. Okay, so for the first one, only one of them has a variable, so C, so the GCF is not going to include that variable. So the GCF is just 4, because 4 goes into 12 and 28. On the second one, they do have an x in common, but just one x, because this only one has 1. This one has 4, so they have 1 in common. So 25 and 15, 5 goes into both of those, so 5x is our GCF. 14 and 42. Well, 7 and 2 both go into those, so that's why I got 14 here, 7 times 2. And then they both have m's and n's. So this one has 3 m's, this one has 8, so they both share 3 in common, so it's going to be n to the third. This one has 2 n's, this one has 3, so they're going to be n to the second. They both share 2. So 14 m to the third, n squared is your GCF of those. Okay. Now if we factor a linear expression, so you can use the distributive property and the work backward strategy to factor a linear expression as a product of its factors. A linear expression is in factored form when it is expressed as the product of its factors. So basically to factor this, we have to pull out the GCF of both of these terms here. So are we going to do that next? No, we're not. Okay, so we'll do it here. So if you look at 8x and 4y, finding the GCF of both of those, well, I know that 4 goes into both 4 and 8, so 4 is going to be the GCF because they don't have any variables in common. So I'm going to take 4 out of 8x, and that's going to leave me with 8x divided by 4 is 2x, because 2x times 4 is going to be 8x, plus sign stays there. If I take 4 out of 4y, 4y divided by 4 is just 1y, or y. That should be our factored form. So now if you can check, you can distribute this back in, and it would be 8x plus 4y. So you're basically, factoring is like undistributing. It's like the opposite of distributing. Okay, so let's look at another example. So factor 3x plus 9. So first find the GCF. So I know the GCF is going to be 3. Okay, and then that's going to go on the outside of the parentheses. And then if you want, you can just divide each term by 3. So you can divide by this by 3. Those will cancel, so I'm left with x plus, divide that by 3. 9 divided by 3 is 3, so x plus 3. And then again, you can check by distributing. And it should get 3x plus 9. So that's your solution there. That is factored. Okay, a couple more. Number 5. So what's the GCF between 12x and 7y? Well, 7 and 12 don't have anything in common. Neither do x and y. So actually this one is not factorable. So not factorable. Okay, next. This one, 18 and 21. Well, I know that 3 is going to go into both of those because this is 3 times 6. This one is 3 times 7. So my GCF is going to be 3. How many p's do they have in common? This one has 2, this one has 1. So there's 1 in common. This one has 3 s's, this one also has 3 s's, so s to the third. Okay, so that's the GCF. So we're going to put that on the outside of the parentheses. So 3p s to the third, parenthesis. And if I take 3 and divide it out of 18, that leaves 6. If I take 1p out, because I'm dividing by 1p, that's going to cancel and leave 1p left. And then I'm dividing by s to the third, which those will both cancel, so I don't put that in at all. Then plus, again, I divide by 3, my GCF, 3p s to the third. 21 divided by 3 is 7. P divided by p goes away. S to the third, those go away because they match. So it's just 6p plus 7. So that is now factored. So you take the GCF, put it on the outside. This is our GCF. And then you can check and distribute it back in, but really you're just dividing each term by the GCF, and whatever remains goes in the inside. Okay. All right, let's try another one. This one has 3 terms. Okay. That means we have to find the GCF of all 3 of these. So what goes into 12, 2, and 24? Well, it can't be bigger than 2 because that's the smallest term. So your GCF, I know 2 goes into 12 and 24. So it's going to be 2. Now, how many x's do they share? This has 3 x's, this has 1 x, this has no x's. So we can't put any x's in the GCF because this one doesn't have any right here. So let's go to y's. There's 1 y, there's 3 y's there because it's y to the third. There's 2 y's there. The smallest one of those is just 1 y, so I can take 1 y out. Now if we look at z's, this one doesn't have any z's. This one has 1, that one has 4. But because the first one doesn't have any, we can't take any z's out. So really your GCF in this one is just 2y. So we take that out, 2y, outside the parentheses. This time I'm going to have 3 terms left. So if I take and divide by 2y, 12 divided by 2 is 6. I still have my x to the third. Y and y cancel. Then I have plus right here. 2 divided by 2 cancels. My y cancels, and I'm left with 2 of them. So I had 3 on top, 1 on the bottom, so 1's going to cancel. So I'm left with x, y squared, still have the z. Divide this one by 2y, 24 divided by 2 is 12. This is a minus, though. So minus 12, y squared over y, so one of them cancels. And then z to the 4th. Okay, and that's what we're left with. And you can check that again by distributing through and seeing if you get the original. Okay, so that is now factored. So that's how you factor something with 3 terms. You just have to take it out of all 3. Okay. All right, I'm going to let you try these. I'll give you a hint. One of these cannot be factored. The rest of them, the other 2 can. Okay, go ahead and try these, factor these, and pause this in 3, 2, 1, pause. All right, so the first one we can take a 4 out of because 4 goes into 4 and 4 goes into 28. And then I'm just left with x minus 7 because 4 times 7 is 28. Okay, the second one is a little tricky. There's a lot going on here. But I know that 3 and 33, they both go into 3. 3 goes into both of those, so that's going to be 3 on the outside. They both have 1 y in common, so I'm going to take those y's out. And they have 1 z in common, so I take a z out. And then left over is going to be my x to the third here, because I didn't take any of those out. My y is gone, and I took 1 z out, so that could become z to the third here, not z to the 4th. Okay, then I have my plus sign. 33 divided by 3 was 11, and then I took both the y and the z out, so just 11 there. So that should be your solution there, factored. And then f, 4x and 35, they don't have anything in common. 35 and 4 don't share any factors, so this one cannot be factored, or it's already fully factored, you could say. Okay, last one. It says the drawing of the garden at the right has a total area of 15x plus 18 square feet. Find possible dimensions. So this is the area. I'm guessing it's talking about this rectangular garden here. So we have 15x here, 18 feet here. So if we factor the dimensions, area is length times width. So what times what equals 15x plus 18? Okay, well, the GCF of those is going to be 3, because 3 goes into 15, and 3 goes into 18. This is 3 times 5 is 15, 3 times 6 is 18, so our GCF is 3. So we can take 3 out here, and then we're going to have 5x plus 6 left over. So that means that one of our lengths has to be 3. The other length has to be 5x plus 6. So that means that this is probably 3. This one is probably 5x plus 6. So here's our 6 times 3 gives us the 18 here. 5x times 3 gives us the 15x here. So our length equals 5x plus 6 feet. Our width is 3 feet. Voila. All right, that is all I have on factoring. So hopefully that jogs your memory on factoring. I know you haven't done it for quite a while, so you are going to be using it though. All right, thanks for watching. See you in the next one.